Okay, in this video we're going to look at doing some polarisation, looking at polarisation and hopefully trying to explain it. Now we're going to use a little bit more technology than normal in this video, mostly because we need to, it's very hard to visualise polarisation, so it's quite nice if I can utilise an animation or two just to allow you to see what's actually going on with polarisation. Okay, so we start off with your understanding of a basic wave, okay, a basic transverse wave. So a basic transverse wave might look something like that, okay? Now, yeah, that's all well and good, but not all waves oscillate in one dimension. In fact, they're all three-dimensional, okay? Which means that we could represent this kind of oscillation of a particle as an up and down in that plane. So it's oscillating up and down, up and down. So we can also get waves which are oscillating in this orientation as well, whilst travelling. So we could represent that as an arrow going backwards and forwards like that. We can also get diagonals. So a diagonal kind of orientation. You can get either side. And actually what we observe here is that if we have all of these waves, we get unpolarized light. And that's actually very common. Unpolarized light is pretty much all the light we see around us, from the sun, from light bulbs, unpolarized for the most part. But it's only when we stick what we like to call a polarizing filter, we can potentially block out certain orientations of these oscillations. And if we block out certain polarizations of the light. So, we'll take you to this animation now. So this is a very simple animation where you can see here that we've got the unpolarized light up here at the top. There's a bit of a mess at the top here because you've got sideways waves, up and down waves, diagonal waves, it's all there. And what we can nicely show is when I press play, we can show that when the waves pass through this filter here, it only allows the orientation of that slit just there, through. So all the other waves are blocked. And so we only allow this vertical orientation. Now, interestingly enough, what happens if we put a second filter in here? Well, we've got a second filter, polarizing filter, and it's still in the same orientation. And actually that means that no other light's going to be blocked. Until I rotate it, however, and you'll see what happens. So as I rotate it, you'll notice the wave that I get out becomes significantly smaller. It doesn't go away. The reason it doesn't go away is because we've still got a component of this wave oscillating in that orientation, and so we can allow that component through. If I put that all the way to 90 degrees, you'll notice that the wave gets blocked entirely and we get nothing coming out this side here. So what happens if we introduce a second slit then? Well, as we can see here, if I rotate this one to 90 degrees, we block that, and I'm going to rotate this one back to 0 there. Obviously this one is doing all the blocking. But what will happen if I start to rotate it? Well, if I rotate it, as I would expect, we would expect it to allow a component of that vertical wave through. And that's what we're seeing. However, what you're noticing as well now is that we've got a little bit still out at the end here, because we have reduced this one to a component of the vertical, and then we reduced this one to a component of what's happening in between those two slits. Interestingly enough, if I rotate this to 90 degrees, if it'll let me, you'll see I'm still getting some through. Whereas when I only had this one and this one, I got nothing. Look what happens when I take away the middle slit. the wave is blocked. When I reintroduce the middle slit and orientate it so that I allow a component through, then because it works stepwise, each one allows for a component which the next one can still transmit a portion of. Which is important to realise about polarisation, is that when you put it through a polarising filter, it will only ever be blocked if you've got a polarised light, will only ever be blocked if you've got a filter that's at 90 degrees to that polarisation of light. So, important to realise, and this is effectively how sunglasses work. They can polarise light and block out proportions of light so it makes it darker and obviously doesn't hurt your eyes as much. So the general concept is there. So that's polarisation. There's nothing hugely mathematical to learn about this in this specification. You just need to be aware qualitatively of what happens and the fact that light can be polarised. Now please bear in mind, these are transverse waves. You cannot polarise a longitudinal wave, and that is really, really important, okay? You should never talk about polarising longitudinal waves because they can't be polarised.